Now see this, we are supposed to find out the eigenvalues and eigenvectors of this matrix. So one interesting thing about this matrix is it is upper triangular matrix, right? Because all the elements below the principal diagonal are 0. So it is upper triangular matrix. So whenever it is a triangular matrix, then finding out either triangular or diagonal, finding out the determinant is easy. And since the characteristic equation is nothing but a kind of determinant, it makes the things simple. So first of all, write the characteristic equation. How can we do it? From the principal diagonal elements, we are supposed to subtract lambda. So now I am subtracting lambda here, and lambda here. Okay, and after doing that, just see this. From the principal diagonal elements, I am subtracting lambda, and lambda. Okay, now we are supposed to find out the determinant. So determinant of any triangular matrix is nothing but product of the diagonal elements. What are the diagonal elements? 2 minus lambda, 2 minus lambda, and 2 minus lambda. That is why determinant is nothing but 2 minus lambda whole cube, and that is equal to 0. Now from this equation we can see that only root that we can get, or only value of lambda we can get, is lambda equal to 2. Even though it is a equation of degree 3, we are supposed to get 3 roots. All the 3 roots happen to be the same, which means 2, 2 and 2. Therefore only eigenvalue for this matrix is 2. In case if it would have been 1, 2 and 3, then the eigenvalues would have been 1, 2 and 3. But here we got only 2. 2 is the only eigenvalue, and from that eigenvalue we are supposed to find out the eigenvector. How can we find out the eigenvector? The same equation, a minus lambda into x equal to 0. So a minus lambda, in place of lambda I am putting 2. Why? Because lambda happened to be 2, only one value. So in place of lambda I am putting 2, a minus lambda into x equal to 0. Then if I substitute in place of lambda 2, and if I write a minus lambda I got this one, this matrix, and this is x1 x2 x3 as usual, equal to 0 0 0, right? And now it is so clear that the rank of this matrix is 2, because this is the biggest square submatrix whose determinant is not equal to 0. Therefore the rank of this matrix is 2, and the number of variables are 3, n equal to 3 and r equal to 2. Therefore n minus r happens to be 1. What does it mean? One of the variable we should assign some initial random value, and others we have to find out using the equations. Now let's see what are the equations here. If you see this one, the first equation clearly states that 0 into x1 plus x2 plus 0 into x3 equal to 0. It means that x2 equal to 0. And the second equation clearly says that 0 into x1 plus 0 into x2 plus 1 into x3 equal to 0. What does it mean? x3 equal to 0. Therefore x2 equal to 0 and x3 equal to 0 are directly straight from the equations. I didn't do anything. Okay, and only one remaining is x1. So for that x1 I am going to assign one variable some random value, right? So I'll choose x1 for that, because x1 is the unknown there. So let me put x1 equal to k. Then x1, x2, x3 happens to be k 0 0. If you pull out k, I get 1 0 0. So what does it mean? The set of all eigenvectors corresponding to lambda equal to 2 is this. So there are infinite number of eigenvectors, and all the eigenvectors will be of this form. If you put k equal to 1, we are going to get this. If you put k equal to 10, we are going to get 10 0 0. These will all be the set of the eigenvectors which are corresponding to this eigenvalue 2. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.